Hello everyone, here is a tricky question from stereochemistry. How many meso compounds are possible for 1, 2, 3 trichlorocyclopropane? Let us first draw the structure. We can draw in 3 different ways. Now you might be thinking this could be meso, but here is the problem. Where is the chiral center? We have a chlorine here. We do have a hidden hydrogen, and then we have chlorine here on this side and one hydrogen down, again chlorine here on this side and one hydrogen down. So do we have 4 different groups around it? No, we don't, and therefore we have to call this molecule simply as achiral or not chiral. We can't say this is meso because we don't have a chiral center, isn't it? Now how about the other possibility? Let's say if I am drawing it this way, let's say I am putting 2 chlorines up and then 1 chlorine down. Is this meso? It would appear like meso because here is the plane of symmetry. You might think that this is a chiral center potentially, this is a chiral center potentially, but can you draw a pair of enantiomers for this? Can you draw a pair of enantiomers? It is not possible to draw a pair of enantiomers for this, isn't it? Because now let's say if you change this here, chlorine, this is also down, only this up, this cannot become an enantiomer, isn't it? Because this is once again would appear like meso, but is it meso? No, it is not meso. It is simply not chiral or achiral. That's the definition you should adapt to. This is achiral, this is also achiral. So when we can say something is a meso, we can say something is a meso provided if you have a pair of enantiomers. If we don't have a pair of enantiomers, then we cannot call it as meso. If you have 1, 2 dichlorocyclopropane, then you will have a pair of enantiomer and one compound, meso compound. So here is the definition from Journal of Chemical Education. An optically inactive member of a set of stereoisomers, at least 2 of which are optically active. What does it mean? It means that if you have 2 optically active compounds, when you can have 2 optically active compounds, that means that you need to have a pair of enantiomers. So in the case of 1, 2 dichlorocyclopropane, we can definitely call this one as meso because we do have a pair of enantiomers. So when you put one up and then other chlorine down, then it's a mirror image, and this one will be, both will be optically active because they are non-superimposable mirror images, isn't it? So these two are enantiomers and this one is meso, but the same definition we cannot apply it here in the case of 1, 2, 3 trichlorocyclopropane. So that's why I mentioned that this is a tricky question. So the number of meso compounds in this case is 0. That's the correct answer.